Good evening, everyone, and welcome to Sky Observers Hangout. Welcome to the Doane Observatory here at the Adler Planetarium. My name is Michelle. It is a delight to have you all with us today. And I'm the Director of Public Observing here at the Adler, and I have many friends joining me in person and online, so.
Yes, and I'm Hunter, Public Observing Educator here at the Adler Planetarium, and we've got lots of help behind the scenes tonight as well, not just us here on camera. Right next to us over here, we've got Dylan, our producer, helping us out on the boards, and then we've got a couple of folks joining us online as well. If you see the Adler Planetarium's name in the chat, that is Bella. She'll be our chat moderator for this evening, so keeping an eye on all of the questions and comments that you all have for us, and feeding those along to us, so let us know if you have them. You'll also see a blue wrench next to Geza's name. He is our friendly resident astronomer that helps with some of those really hard-hitting astronomy questions that I'm sure you all have for us tonight. So thank all of you so much for joining us to help out today. And also hello to our friends at the Farmer's Almanac, and hello to everyone joining us via farmersalmanac.com. We really appreciate them giving us some extra promo for the show, and we love getting to work with them. They are big sharers of astronomy information across the world, so great to have those folks joining us tonight.
Well, Sky Observers Hangout is our place to gather together to nerd out about the sky. If you want to just sit back and watch, that is totally fine. We are here to give you your practical tips and tricks for finding interesting, cool things to view with your eyes or with simple tools. If you would like to do a little more than that, join us in the chat and send us a question or a comment, or share with each other about what you are viewing in the sky right now.
Yeah, we love hearing if you guys are outside observing this stuff right alongside us. We'll give you tips for doing some naked eye viewing of these planets tonight, as well as let us know where you are joining from this evening. So if you're joining from here in Chicago, you should know that after the stream you can also come visit us here at the Planetarium. We'll be open this evening, and Bella will be dropping a link for tickets in the chat. Wednesdays are great because if you're an Illinois resident, you get free admission to the museum. So a great time to come visit us, and following this stream we'll be opening up this observatory for folks to come and look through. So that's great if you live close by, but if you're joining us from further away, you can also always subscribe to the YouTube channel below. That'll keep you in the know on future episodes of Sky Observers Hangout, but also lots of other wonderful content that Adler staff are putting out, including a new one that I picked up, monthly Skywatch videos. So if you want your monthly dose of astronomy and in short format from me, you can get that there too. So lots of reasons to subscribe to the channel, and we appreciate you all coming out to join us for this really exciting show tonight.
Exactly, yeah, let us know in the chat where you're joining from, and I know we always have a bunch of folks in the Chicago area, but we often have people from other countries join us. We have people who join us from other states in the country, so yeah.
And what's great is that this is not such a location specific one, so lots of folks, if it's nighttime where you are, you can get outside and start observing some of these things. So we want to start tonight's show off by talking about really what this phenomenon is all about, what a planetary parade means, and then we'll skip to some observations that you can see a sneak peek of over on that monitor there. So we'll get started talking a little bit about what really makes a planetary parade, right? Now, this term has gained a lot of popularity in recent years. We've seen it especially gain a lot of traction on the news. We see lots of articles coming out when planetary parades happen. And so this is a term that you might be fairly familiar with. Now, despite its prevalent use these days, the exact meaning can be, we've got lots of fun comments already coming in. Sorry, I'm getting distracted.
Oh my gosh, wait. We got to
we'll take a quick pause.
We got to take a quick pause. Hello to our friends joining us from, I hope I'm pronouncing this correctly, forgive me if I'm not, Haridwar, India.
Those are some faraway viewers.
The literal other side of the planet joining us.
I don't know if you can see the planets right now, but I'm glad we can provide some views tonight.
Exactly.
For the folks joining us from Minnesota, Oregon, South Carolina, they can definitely catch it. West Virginia as well. If it's clear where you are, you can definitely catch some of these planets tonight. And if not clear tonight, then in the coming months. So.
And Belmar, New Jersey just saw the space station go overhead, and they waved, and that's exactly what I would do.
That's what we always do when we're out here on Wednesday nights with folks. Is hey, wave to the astronauts. They're up there right now.
Yep. Northeastern Wisconsin. I wonder if that might be Door County. possibly. That would be super cool. One of our favorite places. North Carolina. Oh my goodness, so many places. Oh, thank you so much for joining us, everybody.
Yes.
Let us dive in. You want to see some telescope views of planets, and we want to show you.
Yes, great to see so many folks joining from so many different places. And it's because of course, that popularity of this idea of a planetary parade that has really blown up so much recently. Now, Michelle, what exactly do we mean when we say this term, planetary parade? What does that exactly describe?
So this is an observer's term. It's not necessarily an astronomer's term, but what it refers to is when you can visually spot many different planets in the sky at the same time. And so you can go outside and spot several. And so tonight we've got...
Yeah, we've got, not only do we have, 4 naked eye visible planets up in the sky, like we have here on this sky chart. We even have a couple of more that aren't shown in this image that are too dim for our eyes to see in most conditions, but we can catch through the telescope tonight. So this is an image of the sky right now from Chicago. I think it was set for 5:30 when I took this screenshot. And so these are the locations of these naked eye planets currently. And so we can see that these planetary parades come from the fact that we can spot lots of planets in the sky simultaneously, right? So you can see they might not necessarily be close together. I like to separate this from something like a conjunction, where we'll see 2 planets very near each other in the sky. These don't necessarily have to be close to each other, but they are all present for us to see in the sky at once. So this covers a huge swath of the sky, and we wanted to give this big full sky view to start off so that you can get a better idea of how you can observe it, where to be looking. Down on the bottom there along the horizon, you can see that E and S. Those are east and south. Those are your cardinal directions. So looking to the southwest for Venus and Saturn, looking pretty due south for Jupiter later, and Mars to the east. And we'll continue to give you some more tips for each of those planets as we go through today.
So if the sky is clear for you, which we know it is in Crestwood, Illinois, or in Bolton, Canada, I don't know if it's clear for you.
That one I don't know, but
hopefully everybody gets a chance to see these. All right.
Now that covers a lot of the planetary part, right? But
Right.
what about the parade part of this term? Where do we get this parade part from?
So our solar system, think of our solar system with the sun in the middle and the planets going around it as being flat, like a piece of paper or a plate or something like that, where the planets' orbits are all relatively flat. We don't have them all at wonky angles to each
Right.
other. So if they all appear within the same plane, that means in our sky, they're going to appear along the same line generally. And
Right.
we call that the ecliptic.
So we can see that line actually overlaid here
Yep.
on that same sky image, this sort of new red line you see.
Yeah.
That is called that ecliptic, and it represents essentially that plane that these things are orbiting around.
Exactly. It's not a completely flat solar system. There is a little bit of angle. You can kind of see that represented.
Yeah, and we
too.
can see in this next diagram, they don't line up perfectly with that line, but that's because their orbits can be tilted slightly. So in this next image that shows the big orbits of these planets, you can see they're pretty close but not exact.
Yeah.
So this is where that parade part comes from, right? Because they follow this very similar path in the sky, as the night progresses, you'll watch these planets almost march along in a little parade, folling one after the other across the sky.
As the Earth turns, they will appear to turn across, or they will appear to move across the sky. And setting in the southwest, in this case, we're going to have first Saturn and then Venus.
Yep.
But we're going to take a look at how many tonight?
Six is the plan. 6 is the plan. That's probably the
Yeah.
most objects we've ever looked at in one Sky Observers Hangout. So
It
we're
is.
keeping, if you've been here before, Michelle is telescope operator extraordinaire. So we're keeping her busy tonight, that's for sure. And I think, what time better than the present? As you saw in the last image, we've got some planets setting towards the horizon now. So we are going to go ahead and switch over to our first target for the night. Now we can see, we do have definitely some atmospheric turbulence, little wind. We'll see if we can pull it up. I don't know. I know you might want to mess with settings. As we've been going on, it's been getting darker and darker through our setup. We were setting up during daytime, and so that really changes contrast and things a lot. So fortunately, we've still got Michelle in our feed here working on, and you can even see the things that she's adjusting. So right now, she's adjusting our exposure time, so we start to see more detail. Ooh, I see some questions coming in about how we can observe this. So I see a lot of lights in the sky, but I can't tell which are stars and which are planets. So this is somebody coming from Long Island. So that's a great question. Now, one tip that I always give is, you might be surprised to hear this, but Twinkle Twinkle Little Star actually has some scientific truth to it, and that is because the stars do twinkle in the night sky. Now, under very clear conditions, the planets will not do this. They'll be very solid instances of light, right? You can look at them and they won't waver in that same way. So that's something you can look out for. As we go along, we'll give some tips that are especially useful for some of these other planets that we're looking at tonight. So things like Venus and Jupiter will really stand out because they're very bright. So Venus will stand out even more than any of the stars in the sky. It is the brightest object in the night sky right now, so that can really help. I also really recommend, we were looking at a program called Stellarium Web earlier. This is a web-based program, but they also have an app you can download, and Bella will link that in the chat as well.
Yep, and the Stellarium laptop version is free, as is the web version, so you can follow.
Yep, and actually the app, you can download a free version. That's all I use on my phone. They have some extra features that you can use if you want to pay for it, but it is a mostly open source software and a really great one to use. So that can help with knowing exactly where to look, but Venus will definitely be a lot easier to spot, and Saturn will be nearby, just below it in the sky tonight.
Yep. So go outside right now. If you're in the Eastern time zone in the U.S.
If it's dark where you are.
Right, if it's dark where you are. So go outside and, or in the Central time zone if it's clear where you are. Go outside, face to the southwest. You're going to see an extremely bright object. That's Venus. Saturn is going to be a little bit below it and to the right. Now, depending on how far east you are right now, it's going to be lower in the sky. So you may have the hardest time spotting Saturn. But if you don't see it tonight, try to go out tomorrow night. It'll still be there. So
and hang around, and we'll give you more tips about some of these other planets that won't be setting so soon either, and it'll be a little bit easier to spot in the sky. So stick around and you'll get lots more tips related to that, as will the person joining from Riverside who's curious about how Uranus will look in this telescope. Oh, just you wait, we'll get there. We got a couple of targets to get to first, but we'll see if we can spot the moons, and we'll see how Uranus looks.
And can we see the moons of Uranus? I don't think so.
I don't know. Based on the conditions I'm seeing right now with the kind of, shifty stuff, we'll have to find out later. We'll
overexpose it and see what we get.
Exactly. There you go. Now, to start the night off, we're looking at, what is really the favorite of many, the planet that I've seen the most visceral reactions out of people when they've looked at it the first time, and a very common one when people ask, when people are asked, what is your favorite planet, right? This one is Saturn that we're starting with, right? Now, one thing that I appreciate about looking at Saturn and seeing it set towards the horizon tonight is just how special planetary parades can be, right? They can be, while they're not these big astronomical events that we talk about, like maybe a solar eclipse or something like that, right, where we've got lots of astronomers going to study these things, they are still fairly rare, especially having 6 planets up at once, right? So these are not always in the sky, and Saturn really exemplifies this right now, right? It'll be setting soon, and as we get later into the year, it'll set earlier and earlier, and eventually it will only be up during the daytime. So now's really your chance to see Saturn. Now, the big thing we always look out for when we look at Saturn, there's one thing that everybody knows Saturn for, and it's those big rings, but I don't know, I'm looking here at our screen and they're a little tough to see. What's going on there, Michelle?
So what's happening is we are approaching a point where Saturn's rings are going to look basically edge on, and that's going to happen in March of this year. We'll talk about why we're not actually really going to be able to see that per se, that best day, which is near the end of March. But as Saturn goes around the sun, sorry, I should back up. Saturn has a tilt, just like Earth has a tilt. The planets have different tilts, but Saturn has a tilt. And that tilt stays constant. As Saturn goes around the sun, that tilt does stay constant, but then at periodic times, as you see our perspective of Saturn with its rings, sometimes you see them edge on, and sometimes we see them more face on. But we're approaching the point where we see them more edge on, just like that. And so if you're looking at the screen, you're going, I don't see them very well.
Where's the rings?
That's the point.
So maybe we should compare this image to one we took back in September of 2021, right?
Yeah.
So this is, just 4.5 years ago. Is my math right? 3.5 years ago, sorry.
Right.
you can see that it was a very, very different view of Saturn. I mean, this is more magnified. This is a cropped version of the image that we took. But we can really notice a drastic difference in how it appears, right? We can see much more of those rings. We can even see the Cassini division, right? That dark gap that we're noticing in the rings here. So very drastically different. So right now it is moving towards being totally edge-on, which will hit in March.
Yep.
And then it'll do that again, actually in November of this year. But then after that, it will continue to tilt more and more away, or appear to tilt more and more away until we are seeing these big nice rings like this. So in this next image, we can actually see simulated views from Stellarium as well, how that tilt will change over the coming years. And it's kind of in this constant cycle of tilting away from us one way, coming back, tilting away from us the other way as our position relative to Saturn changes.
So
right?
and by the way, when we're saying it tilts one way or the other, Saturn is not flopping around.
Right.
So it's not doing that, just like Earth doesn't do that either.
Mm-hmm.
It's that our perspective of how we view it, our angle with respect, our viewing angle with respect to Saturn's rings is what changes. And so we're approaching that edge-on point in about a couple months from now, actually. So.
Yep. Now, one thing that can be useful with ring crossings is while they might make Saturn appear a little less visually interesting to us observers, right? There can be some useful bits that can come out research-wise with these ring crossings. Now, this image is from one that happened back in the 90s. These don't happen very frequently. The next one after this year is not going to be until 2038, I believe. Yep. So these are pretty infrequent, right? And so this was some imaging from Hubble back in 1995. And you know, what kind of things were they looking for when imaging a ring crossing like this?
Primarily moons. So this is a great time to look for fainter moons that might be embedded in Saturn's rings or very near Saturn's rings. Because if the ring material, if we see it brighter when the rings are more, they appear more open, then those moons are just going to be harder to spot because we're frankly talking about really small stuff.
Right.
But when you take away the brightness of Saturn's rings, when you basically you're just seeing them from the edge, then that might make some of those moons a little bit easier to see, especially since Saturn's rings, the thickness of Saturn's rings on average is only about 30 feet. That's about 10 meters. I'll say that one more time. Saturn's rings are about 30 feet.
It's incredible to think of when we look at these images and see how defined they are from here, how well we can see them.
It looks like they
to
must
be so thin and skinny. That's crazy. So it's no wonder they're tough to spot right now.
No, about 10 meters or about 30 feet thick. And so if you've got something that's thicker than that, it might show up.
Right, so even these little moons held within the rings, they could actually spot in those images.
Right.
And so, you know, now that we look back at this live view of Saturn, which I will notice our atmospheric conditions are not amazing today.
Yeah, I knew.
But hey, it's better than it being cloudy. We'll take it. So we've got a fairly clear sky and it's pretty warm tonight. So we can appreciate what we can get. But it might be interesting to see if you up the exposure time, can we spot any of its other moons around it?
I'll do that.
Before we shift over to a different object. There we go. So we mentioned some of its moons. Now its smaller moons are still hidden within those rings, but as we up this exposure, a little too long.
Sorry.
But we can start to see some of those moons come into view around the edges, right? So we've got 4 of these moons of Saturn visible. Now, when you look at Saturn through a telescope, this is something that always blows me away. That's very different from, you know, astrophotography versus visual observing. Is that the camera, while it is unable to have something bright like Saturn and something dim like its moons really clearly visible at the same time, right? We have to mess with these exposure times to make it possible. Our eyes really adjust to this well. And if we were to observe Saturn tonight, you know, with our eyeballs up to the telescope, you would see all of these moons and Saturn simultaneously in much better detail than the camera can see, which always interests me.
By the way, if you're wondering which moons these are, I'm looking it up right now. We've got
from left to right,
Rhea. Then I think it's Tethys. I think that's the next one is Tethys or Tethys, either one. Then Mimas. Wait, am I getting that right? And then Doane. I think that's right. Yeah. I may have them backwards. Do I have them backwards? Doane, Mimas. Anyway,
wow.
Rhea, Tethys, Mimas, and Doane It's either left to right or right to left.
That's left to right. Yeah, that sounds right.
So anyway,
I love this story from Geza that he posted in the chat. This is why we love having Geza around. When Galileo first discovered Saturn, its rings were very apparent. We have to remember that his telescope was not very good.
Right.
So he wasn't getting much detail. A couple years later, they disappeared, and he thought that they were just gone. That they weren't there anymore.
Yeah.
He's the first person to ever see this stuff.
Right. And
incredible.
People thought Saturn through telescopes looked like it had ears.
Which I can see, you look at this overexposed image, and I can see, that idea coming up. That kind of makes sense.
Yep. So,
well, I think that rounds us off for our first one of the night. And I mean, we've got so many more to view. We're already 20 minutes in. Let's see what our next target of the night is.
All right, in a second.
Now, this one you got a sneak peek already in the stellarium view, showing the full view of the sky. You might have just seen the telescope move a little bit. Next one we're going for is going to be Venus. Now, this one is one that will be very easy for you to spot in the night sky if you go out right now. Now, Venus, you might not see it for super long tonight. It'll set in a couple of hours. But while it is up, it is incredibly bright. So get outside, look to the southwest up in the sky. If you see something that you think, oh my God, is that an airplane or something that doesn't look like the stars I know? That's going to be Venus. It really, really stands out. It is brighter than everything else in the night sky right now. Only things that outshine it in the sky are the moon and the sun. So this is a great one right now. And man, look at that view.
There you go.
So some things you'll notice on our live views tonight is some kind of shifting of the image. This just comes down to atmospheric conditions. While it is pretty clear tonight, it's still a little windy, just kind of getting over some high winds that we had earlier in the week. So you'll see images kind of jump around a little bit here and there, but when we get those really still moments, it looks great. Now, we've got Venus in view here, and there's one thing that really differs Venus from the other planets we're looking at tonight, and that is that it is inferior to the Earth. Now, when I tell people that, I always want to make sure they know. I do not mean that Venus is a lesser planet than the Earth. It's not worse than the Earth. I'm not ranking them here, though I probably would put it a step below Earth if I'm going to be honest.
I don't know. It's a pretty interesting place.
It's interesting, but kind of deadly. Too hot for my liking.
There is that.
But in astronomy terms, inferior refers to it being closer to the sun
Correct.
in its orbit than the Earth is.
Yep.
And this results in, some good sides and bad sides of observing Venus. So what are the goods and the bads here?
So what the good part is that as Venus goes around the sun, different parts of it, we see the different illuminated parts of it. So half of Venus is always lit by the sun. How much of that half we see is its phases. And just like our moon goes through phases, Venus goes through phases as well. So we can see that. So tonight we have about a 40% Venus.
Yeah, this is a great night to get to talk about this. It's a really, really distinct phase, and it goes through these phases much in the same way that that our moon does, right?
Exactly.
And so we get to see it change. Which illuminated part we are seeing, how much of that illuminated section of the planet we're seeing, and that goes back again to our Galileo story from earlier. He comes up a lot when we observe planets, right?
Yeah.
And him seeing these phases around Venus was a really revolutionary discovery, right? Sitting there and trying to calculate the geometry for how this was possible is what helped really push the Copernican revolution forwards, and helped them realize there's no chance that Venus and the sun are both orbiting around the Earth, because these phases that we're seeing just simply wouldn't be possible.
Yep.
And so it was a really big moment.
Someone has a really great question that actually ties into one of the bad sides about Venus being closer to the sun than us. Could Venus be brighter in our sky in full phase? Let's think about when full phase actually happens,
Right.
when you would see most of a Venus.
That's a good question. I haven't thought about this one actually. I like that question.
When is Venus brightest? And when does that happen? Well, to see Venus in full phase, I'll answer that question in a sec. To see Venus in full phase, or as full as we're gonna get, you need to see the entirety of the side that's lit.
Mm-hmm.
And that would be when Venus is basically on the other side of the sun.
Right. So it has to be opposite side of the sun for us.
Correct. That would mean it is smallest in the sky. That would mean the sun is in the sky at the same time. So you're not going to see it. Or it'll be extremely difficult to see it. because it'll just be very, very, very near the sun. When Venus would be at its largest in our sky, it would need to be closest to us, on the same side as the Earth, but then that's the shadowed side.
Right, it can be a very thin phase.
Right.
So it's an interesting balance of, we need it to be at a long elongation from the sun in the sky, right? So far away from the sun in our sky, but also pretty well lit. So if I'm going to be honest, a phase like this is great. This is when it's going to be very bright, very far from the sun, enough of it's illuminated that we really see a decent amount.
So even though when Venus is approaching what we call greatest elongation, when it's at its farthest apparent distance from the sun, basically it's at a 90-degree angle between the sun, Venus, and Earth. There's a 90-degree angle there. That's when you would see basically a half Venus.
Half of the illuminated side, right? So you would have, perfect semicircle. Right?
You could say first quarter Venus or third quarter Venus, depending on which side of the sun it's on. But then as Venus is still orbiting the sun and getting more in between Earth and the sun, you then see crescent, more of a crescent Venus. And so you just have to get that nice, perfect combination of brightness and bigness, because as it comes in between Earth and the sun, it's gonna get even a little bigger in the sky. So approximately first quarter Venus or third quarter Venus is when Venus is going to be at its brightest. So it's going to be at its brightest coming up in February.
It's a great question.
Awesome question.
A couple other things I wanted to mention from the chat. Hello to the Two Rivers Observatory. Thanks for coming and checking out our stream tonight.
Hey, Two Rivers Observatory, where are you? Please let everybody know where you are.
I was wondering which two rivers it was referring to. So we might have folks in the chat from nearby. So feel free to let folks know where you guys are. And could people come visit you? I don't know if you're a public observatory or not. So if you don't want hordes of people coming to visit you, then don't put your address. Where you are, because they might chill.
Anyway.
So another question that we had is, do all planets have phases from our perspective, or just those closer to the sun? So that second part is exactly right. We just have two that experience phases.
Correct.
Venus and then Mercury.
Correct.
Now, Mercury suffers even more than Venus in this always being close to the sun problem, because its orbit is even closer. It's particularly difficult to see, and I personally have never seen it to the observatory telescope. I don't know if it's ever been really high enough in the sky for us to spot, or far enough away from the sun, so it's a really tough one. But yeah, just those two experience that. You can imagine it's because the other planets, because they're further away from us, when they're on our side of the sun, there's no phases happening because we're still looking outwards at that fully illuminated side. They have very, very slight phases, but nothing that you're really going to notice to the eye. So, now, one other thing I wanted to talk about with Venus is that, the phases are interesting, but other than that, I don't get a lot of detail on here. So, what exactly are we looking at when we are looking at Venus?
Just like one of the worst times to look up at the sky is when it's totally clouded over. Worst time to ever look at Venus is all the time, because it is completely clouded over. Yep. So Venus is totally covered by clouds. It makes it extraordinarily reflective in our sky. So its brightness is due to its bigness and its reflectiveness because of those clouds. But it means we don't see any surface features, and those clouds really don't have a lot of readily apparent features either. So we're just not seeing all that much detail. I just love the fact, if you take a look at that line, that shadow line though, notice it's kind of fuzzy. You're seeing the atmosphere of Venus. You're seeing those clouds. If there were no clouds there, if there was no atmosphere, it would be a very sharp line, more than likely. Just like we see on the moon.
Right, on the moon, where we have very distinct boundaries.
But you're seeing it get a little bit dimmer at that shadow line. You're seeing it be kind of fuzzy at that shadow line. You're seeing the actual atmosphere of Venus, which I think is
incredible
really
stuff.
Cool.
Incredible stuff. I did say this. Somebody said that this is making them want to buy a telescope. I gotta say, sometimes when we look at stuff with this telescope, I'm like, be careful, it doesn't look like this. With the planets, this is a time where I can be like, yeah, the planets look really good through an Allen telescope. And actually, when it comes to planets, I like observing them with my eye even more than a camera sometimes.
Just remember one thing. I have this artificially zoomed in.
That's true. This is bigger than it'll appear, especially if you have a smaller telescope. Yes. But you can really get some nice detail. And we have a blog on our website written by the Michelle Nichols, all about getting your first telescope and what kind of ranges and some good ones to check out. So it can be a little intimidating, and there are some what we call hobby killers out there, some really not worthwhile telescopes that can kind of lower your spirits a little bit. So I'd really recommend checking that out if you're interested in it.
Somebody was asking, are the phases of Venus and Mercury the same as our moon? Would we call them first quarter, etc.? I think so.
I do believe that they have all the same names. It goes through very similar phases as we see on the moon. All the same ones.
Venus, crescent Venus. Mm-hmm. Yeah, the first quarter and third quarter part might. I've seen it referred to as that, or half Venus. I mean, you can't really go wrong. So.
We'll see what Geza thinks in the chat too. He might have some opinions on this as well.
Oh, sure.
So we'll see. We love hearing Geza's thoughts. Now, one thing that I did want to mention is that, from here on Earth, we do have some trouble really seeing through those cloud tops of Venus.
Yeah.
We've had some, huge leaps and bounds in astronomy over the last, 50 years or so, where we have sent so many things out into space that have really helped us reveal even more about these planets. So these days, not with an at-home I guess this isn't much of an at-home telescope, but standard Earth-based telescopes. If you've got one of these at home, you're really lucky. This is not what mine looks like.
No.
It's about this big and sits on a table.
Mine's a 10-inch telescope, but I built it. So, it's still not this. Yeah.
And so, nowadays we are able to send these things up that are looking at planets in such different ways and really get to reveal very different views of them. Glad we've got some second graders in Chicago that are watching.
Hello, Shayna.
Tonight. Nice to have you here,
Second
Shayna.
grader in Chicago who is loving our show. We are loving that you're watching our show. Thank you for watching our show.
Come out sometime on a free Wednesday night. Come visit us.
Come on out. Bring the family with. Come on down.
I do think that's required, actually, for second graders to visit. We do need to have some grown-ups with us.
Make sure there's a grown-up with you. All right.
So these other views of Venus that we have that are possible these days, are because of orbiters actually going to visit Venus and imaging using very different methods. So the left one here is some UV imaging from the Pioneer orbiter that took this in 1979 that really allows us to see more details in those clouds. And then later in the 90s with the Magellan orbiter, they were able to basically take radar images of the surface and map it that way to give us this view of what the surface actually might look like without all of that thick atmosphere.
Yeah, if you stripped away the clouds, this radar image is representing the bumpiness or the smoothness of the surface. So if you see dark on a radar image, it's very smooth. The terrain is very smooth. If you see bright on a radar image, it's a very bumpy terrain. And so there's all sorts of different kinds of terrain and features and things on Venus. And we're hoping that some spacecraft get sent to Venus in the next decade or so.
Always hard to time these things out. There's so many missions going on.
Yeah.
It's hard to know exactly when they'll launch. But we've got it in the works. Now, because our next target is so different than this one, I might geek out for a little bit over some Venus surface images, but if you want to start working on getting us pointed at our next target for this evening.
Want to take one last look at Venus?
Yeah, maybe we should get one last telescope view before you switch over. Appreciate that lovely phase we have. And then while you work on our next exciting target for the night, I can keep geeking out about Venus.
Surface features of Venus. Go for it.
Surface features of Venus, yes. So if we take it back into those images, so those ones were taken from orbiters around the outside of Venus, right? But also in the 80s, one thing that I think is so interesting is we actually got a real glimpse of what that surface looked like. Now, these glimpses were brief. They didn't last very long, and we only have a couple of images. Really, what you see here is pretty close to the extent of the images we have of Venus. There's a few other ones that look very similar to these shots that we have here. These are coming from the Venera missions that the USSR was sending up during the 80s. So this one was from Venera 13. It was taken in 1982. Now, Venus's conditions are really brutal. That thick atmosphere that's full of all of those really dense clouds that we were looking at is, the cause for so many difficulties there. So it makes it hundreds and hundreds of degrees on the surface surface. The pressure is very, very high. So this high pressure, these high temperatures, make it incredibly difficult to prepare a lander to really make it onto the surface of the planet. So we've got a couple instances, they only lasted like 30 seconds, and then their systems were fried. So they were able to give us a few images on each of these missions. I think one set of images from each one after it was on the ground. And you can really start to see what Venus is like. You can feel almost how dense that atmosphere is with that yellow coloration you see, all the sulfur that's up there in that atmosphere. The cracked appearances of the rocks really, gives us that feeling of the heat there. So while it might be very interesting for these reasons, this is why I said earlier it doesn't seem like such a nice place to visit. Those are the actual colors that you would see there. That is just what the atmosphere is like. It's a pretty brutal place. Now, this object that we were looking at here, Venus, is very bright in the night sky. You should go out and check it out yourself. But we're going to shift away from some of our naked eye targets tonight that we were looking at with Saturn and Venus, and then with Jupiter and Mars that we'll have later. And we're going to shift over to some of our more dim targets that we'll be looking at tonight. Oh, before we shift to not talking about Venus, one more question in the chat that was a good one. Why does Venus rotate in the opposite direction to most planets?
Boy, we wish we knew the answer to that question.
It's a tough one, as in many things in astronomy, right? This stuff started way before we could figure it out, right? It's always been rotating the wrong way, so we don't have any physical evidence that we can go and look to, right?
Yep.
And so, anything we say is really our best educated guess, as we think right now.
Did it get hit by something early on in its history that slowed down its rotation or made it go in a different direction? Don't know.
Right. It's really hard to know. That's our best guess. That's how it goes with a lot of the kind of unique things that we notice in the solar system. We often chalk them up to some sort of, interaction between large bodies. Uranus being another example, with its sort of sideways tilt that it has. We often chalk it up to stuff probably smashed into each other in the early solar system. Now, next one we're looking at here, much less bright than Venus, and one that unfortunately I cannot recommend you go out and look at yourself unless you're a very experienced observer. We're into the dim section
Yes.
Of the show. So
Yes.
What are we looking at here in this view?
This is Neptune. And if you're going, wow, that's not much. That's kind of the point. So Neptune is dimmer than you can see with your naked eye. You cannot see it, but it is a little disk. And we have, I don't know if you were noticing, if you could see, some of you, if you're watching on a phone, it might not come through very well, but we've got our camera settings on the right side of the screen there. And you may have seen that for Venus, I had the camera setting as low as it could go in terms of the exposure time. So it was as short as possible. This one is about almost 2.5 seconds for an exposure time. So it is changing an image, a single frame, every 2.5 seconds. And that's because it is kind of dim.
Right. And to give you some perspective here, why it looks so small. Neptune isn't necessarily a small planet. It's much bigger than Venus that we were looking at before, right? Its physical dimensions actually out in the solar system, but it's really far away. Yeah. It's currently 30 times further away from the Earth than we are from the sun. 30 times further away. Once you get out into these outer planets, their orbits, the distances between those orbits gets much, much further away. So while Neptune might be big, it's just really far. It's just really far, and no matter what kind of big telescope we have, it's still gonna appear really, really small when we observe it. It's just so far away from us.
Yep. But you might notice we do have the color camera on our telescope tonight.
Trying to see if I can see it.
There is a little bit of a blue tint.
Especially around the outer edges where it's a little dimmer. You can see that blue tint. I don't know how well that'll come through on the stream.
Right.
But when you do look at these through a telescope, through a large one like this, you can notice that blue tint.
One thing to remember though, if you've seen pictures of Neptune, anytime taken from in the last, or actually the ones that we generally see are the ones taken by Voyager 2 in 1989, and then Hubble as well. But a lot of the images you might have seen as this deep, vibrant blue color. turns out that a lot of the images that have been published, especially the Voyager 2 images, those were color enhanced. Neptune's color is actually about the same color as Uranus.
And this was some pretty recent research too. It's always been shown as like very dark blue in comparison.
Blue. Yeah, it's not.
Almost violet or indigo or something, right? But turns out it's probably just another pale blue one. They're maybe more similar than we expected.
Yep, it's all thanks to the methane that's in the atmospheres of Uranus and Neptune. It absorbs colors and reflects kind of a light blue color.
Right.
Yep.
Now, Neptune is super interesting because out of all of the planets that we'll look at today, Neptune was actually not discovered through observation. It was actually originally discovered through math, believe it or not. So while it was visible from the time of the first telescopes being invented, it was not recognized as a planet. So this is the very earliest observations of Neptune to ever happen, and they were actually totally accidental and not labeled. It was not labeled as a planet at this time. So this is from a notebook of Galileo's when he was observing Jupiter, marking where its moons were, and this little dot that you see on the side labeled Fixa. This is how he would label these different stars that he would notice. Turns out we think that was actually where Neptune was at that point, and that he was the first person to really observe this planet. He had no idea. He had no idea at this time.
Yeah,
so
the fixed stars versus the wandering planets.
Exactly.
So,
Yep. And so this was technically the first known observation that we have, but it doesn't come until almost 200 years after these observations, or actually even more, that we actually learn that it's a planet. It's because of some interesting math that they were doing to make this possible. Can you tell a little bit about that mathematical story?
Yeah, a little bit. So Uranus was discovered in 1781 by an astronomer by the name of William Herschel.
Yep, and we'll talk a little bit about that when we observe Uranus too. So.
Yep. If you come to the Adler Planetarium, you can see we have a telescope from William Herschel on display. You
Don't
can
get to see the picture of it.
Yeah. So and the observations of Uranus, though, were really interesting because it wasn't exactly where astronomers expected it to be over time. They would chart its position in the solar system over time, and it wasn't quite where it needed to be. Basically, they could account for its position if there was something out past Uranus tugging on it gravitationally, and so it was mathematically figured out by a couple different astronomer teams, one in England and I think one in Germany, if I'm not mistaken, that, approximately here is where it should be in the sky. Adams and Leverrier were the last names of the astronomers who did this work. And lo and behold, wasn't too much of a search.
Impressive recollection of the names, by the way, Michelle.
Thanks.
I did not write those names down anywhere.
I am a font of useless knowledge, as I like to say.
Very useful today.
Actually, very useful today, and really great for Trivial Pursuit. Anyway, so Adams and Leverrier both mathematically figured out an approximate location for this object where it should be, and lo and behold, not too far from where they found it, or where they expected it to be, is where it was actually
they
found.
went and scanned the sky, and eventually they got even a worse telescope view than we're seeing here tonight, but they were able to spot that planet, see that little blue tint, that it had more dimension than the stars had to them. I'm guessing they probably couldn't spot any of its moons back then, but I think they might actually have one with our telescope tonight, which is either that or a star in the background.
I think it's a background star.
Think so?
Yeah, I wasn't
sure.
Yeah, I was looking up the brightness of Neptune's largest moon, Triton, and it is about 14th magnitude.
That's right on the edge for us.
It's right on the edge for us. If
in good conditions and
if
long
in good
exposures.
Conditions, and it's higher up in the sky, and it's a much longer exposure. So I don't think
it might just be background.
Yeah, I'm pretty
sure.
sure.
Won't promise anything.
Yeah, I don't think a 2.5 second image would get it. So anyway.
But I think it's such a cool discovery story. First planet discovered just through math alone.
Yep.
And really shows you the dimness of these objects.
Exactly, and it's really cool to be able to see this. Because it's a planet we normally aren't able to show folks if you come and visit, because it's just rather hard to spot.
It's hard to see. It's hard to tell that it's different from the stars around it. When we're looking at things like Jupiter, Saturn, it's so obvious what we're looking at.
Right.
The excitement of Neptune is a little bit harder to see immediately.
Yeah, this is another example of of something through the telescope, even through our 24-inch wide telescope, it's just not going to appear that big.
Yeah, it's just so far.
Yeah.
You know, that's how space goes.
Yep.
That's part of
It's
the
just
expectations.
how space goes.
But yeah, there's a lot of it out there. Empty space.
Let's see. How many moons does Uranus have? I believe it's 27.
What are we up to? Yeah, we're up to a pretty high number now. These kinds of numbers keep getting higher and higher as we have, more missions going out there. Geza.
Hey, Geza, can you confirm
Could you post that in the
27,
chat for us?
please?
Yeah, thank you. And throw the Neptune number in there while you're at it.
Oh wait,
Put those
Uranus.
moon numbers down.
Yeah. I think it's 27 for Uranus and 14 for Neptune.
It's hard to remember. They're constantly changing. So
Those could
as
be
we
old
discover new
numbers.
ones, it could be old news. Yeah. But
Anyway.
while we're on the topic of Uranus, that is going to be our next observing target for
Right.
tonight, and I think we're about
Shall
ready
we?
to move over to it. Yeah, I think so.
Let's go.
Now this one might take just a minute longer, only because it's in a separate part of the sky and we'll have to spin the roof a little bit. So actually, fun opportunity to check out the telescope moving around while we take a look. Here it goes, switching over to the new part of the sky
Right,
that
gotta
we'll be
move the
observing
roof.
tonight.
All right, gotta move the roof.
All right, sorry, it might be a little loud. Pretty close, yep. Alrighty, Mike's back. Geza confirmed 28, so close, Michelle.
close.
27 was certainly accurate at some point. Because these moons, a lot of these are really, really small, and we continue to discover more and more around lots of them. Yeah, sorry, we cut the sound because the roof was so loud. It's a little squeaky in here. We've got an old roof in here. Building was built in 1977. We've got a much newer telescope here, but roof's still the old one. So next we're going to switch our targets to Uranus, another very similar object to Neptune. They're both these big icy giants.
Hang on, I gotta move a little bit.
Moving the roof a little bit more. Okay, sorry. Okay, that should be better. So sorry about that. Trying to not have any horrible noises for your ears there at home, especially if you're watching with headphones on. Oh, great question. How did they find out Neptune is a planet? So when they're looking at it back then, it even did stand out as, distinct from the stars. So while it is small, it's not an exact point of light. You can tell that it is a disk when looking at it through the telescope, right? It looked larger than just that individual point of light. Another thing that they can watch for that's really, really helpful, and we were going to talk a little bit more about this while looking at Uranus, but we might as well talk about it now, is that planets change their position relative to the stars in the background. So over time, over, let's say, a year, right, the stars do not change position compared to each other, right? So the constellations that you see this year will appear the same when you look at them next year, right? They change their location in the sky as the year changes, but they don't change, their distance between each other. Planets work a little differently. Because they are so much closer to the Earth than those very distant stars, that means that the planets change their position in the sky. So where Jupiter is today, right now you could go out and you'll see it right above Orion. Look again in a couple of months and you'll notice it's in a very different spot in the sky. A great place that you can actually look at this and see some changes just over the next couple of weeks is when observing Mars. So right now you can see Mars relative to a couple of stars in the constellation Gemini. And there's these two stars right next to each other with Mars just below them right now. If you watch in the next couple of weeks, Mars will change its position relative to them. Keep going out every night that the sky is clear and see where Mars is relative to those stars. Right now it's down kind of below them, but come a couple of weeks, it'll make a little triangle with Castor and Pollux, those stars from Gemini. So, good little experiment that you can do, and they can see these same kinds of things happening on planets like Uranus and Neptune. And that's where we actually got the name planet from. Okay, so now we've got Uranus in view, and you'll see.
Oh, here, I'll move
You're
it.
gonna adjust the
I'll move
position
it,
a little bit?
yeah,
Yeah, sure.
just a little bit.
not such a different view from Neptune, right? So they're very similar in size. While Uranus is technically a little bit closer, the difference between the two is it is not such a big enough difference that they appear that different
By the way,
from here on Earth.
if you're wondering how I changed the position of the telescope quickly, it's with a game controller. So that's what I can do to actually move it. So if I take this little knob right here and go like that.
Here it goes. By Uranus.
There you go.
It's interesting when it shifts like that. You can actually see the color a little bit better when it's almost smeared out.
Yeah.
It's not so bright in that individual spot.
Yeah, you definitely can. So.
But honestly, I already see a little bit more distinct color in Uranus than I did with Neptune. Now, what's fascinating to me is that while these appear very, very similar, the difference in brightness between them is enough for Uranus to technically be naked eye visible. Now, I'm going to say that's a very hard technically here. What kind of conditions do you need to be in to really see Uranus with just your eyes?
Basically, the darkest skies imaginable, pretty much. So you need to have no light pollution whatsoever, and just get out far from any lights. And you have to have really good eyesight in order to do that too. So for most of us, we're not going to see.
Another thing I'd add is that you really have to have a very, very good knowledge of the sky, because to see an object as dim as Uranus, you're going to see so many stars, thousands, literally thousands.
Yep.
And so it's really, really hard to spot naked eye. We do have some, documented observations of it long before the telescope came out. The earliest one being from, around 100 BC is when it was coming from. 128 BC, we have the Almagest being published by Ptolemy, and that included some observations from Hipparchus where he did note an object in the spot that Uranus should have been in. So it was documented there as a star, but which proves that he could see it without a telescope. This is millennia before the telescope is invented, and he was able to see it with his eyes. So it's possible, but...
By the way, one way we can show them the color a little bit more easily is if I defocus
You could defocus it if you want to. Yeah, it does really help bring out the blue. And Neptune would have shown very similarly to this one.
Okay.
So we'll see how this brings out the color.
So the focus for the telescope is right here. So.
Yep, the little blue blinking light is actually the camera itself. Camera's kind of heavy, so it's a little slow to move sometimes, but you'll see Uranus almost turn into like a big donut-y ring. Oh, yep.
Sorry, hang on.
Started to do it there.
Sorry. I went a little too far.
There we go.
There you go.
That really brings out the color.
Oh, that's cool.
So this is a frequent problem I see people have when they're new to telescopes. They're like, why does it look like a donut? Why is there this weird ring? It just means you're not at perfect focus. You want to get your objects as small as possible. But it does really help with the color. I mean, you can really see that distinct blue.
I'm going to snap a picture of that.
Sure, go ahead, go ahead. So these colors all come down to the composition of these atmospheres. We see these same, these different kinds of gases in the atmosphere also account for things like Venus's color, Saturn's color, Jupiter's color, lots of things like this. Ooh, question from the chat. How often do you broadcast with the telescope? Well, right now we're on about like once every 2 months. We try to hit about 6 shows a year. Our next one coming up, which isn't on our YouTube yet, but we can give you a little sneak peek to, will be, well, it's technically the night of March 13th, but the show doesn't start until midnight on March 14th, where we will be observing a total lunar eclipse from down in southern Illinois. But you can also go back and watch all of our old streams. So they are all saved as videos on the Adler's YouTube channel. You can find the Sky Observers Hangout playlist. If you go to our live section on our channel, you'll see all of the streams. So there's lots of content that you can get there. Some including telescope views, some seeing through other telescopes, some that are just observing tips. So there's lots of content out there for you to go and check out. It's been running for a couple of years. And we're up to, this is episode 44 now. So
yes,
we've got lots of them.
We've been going since basically fall of 2020,
right?
Yes. But it's been since the Adler reopened in March of 22 is when we started really using the observatory.
Right.
For
some of those earlier ones were more at-home ones.
Which binoculars are best for seeing planets? Okay, so there's a few different answers. When you're looking at binoculars, there are 2 numbers on the sides of binoculars, and it'll be a number and then the letter X and then another number. The first number is the amount of magnification. So If there's a 10, it means it magnifies something 10 times. If there's a 12, it means it magnifies something 12 times, and so on. The second number, so 10x, we say by, 10 by, and then 50 or 70
Sometimes
or
70,
something
sometimes
like that.
lower, like 30 or something.
That refers to the diameter of the main lenses in millimeters. And so what do you want? You want a good combination of magnification and sizes of those main lenses, the lens up front, because the bigger the upfront lens, the more light the binoculars gather and the brighter the object that can be seen. So you're thinking, oh, you want to crank that number up, right? You want it to be huge. Well,
certainly that's the goal sometimes, but that can cause some problems, right?
Because the bigger those lenses are, the heavier your binoculars are going to be.
Hard to keep them steady,
correct.
right?
Yep. So if you want to view planets, something, I'd say the maximum type of binocular you want is something like a 15 by 70 or a 12 by 70 or something like that. Anything bigger than that is going to be hard to hold. They do make image
tripods.
They make tripods that you can put binoculars onto, but at that point you might as well get a telescope. They also make image stabilized binoculars, but those are going to be expensive. So 10 by 50 is kind of a standard size. That's a decent size. But just remember, the planets are going to be tiny little disks. So anything lower than that in magnification, you're not going to see much. Anything bigger than maybe 50 or 70 millimeters, they're just going to be too heavy to hold on to.
I think that you should also have some particular binocular recommendations in that blog that we mentioned earlier as well, I believe, right? Are there some binoculars in there, or is it just telescopes?
I believe it's just telescopes.
Okay. Well,
there's
either way,
there's a lot of decent manufacturers.
What I would also say is, binoculars are fantastic observing tools. Planets aren't necessarily their specialty. They're better at big wide field stuff, star clusters, things like this. They're great for scanning the sky. Sometimes, they might not provide the best planetary views because you really are going for magnification, and that's tough with something that's handheld. So for planets, I would encourage even, a small telescope as being a more optimal tool for it, but I don't want to discourage you from binoculars because they are a great observing tool. Planets just probably aren't their specialty, I'd say.
Right. Binoculars are great for the moon,
and
Orion Nebula.
Right, starting to learn the sky too, and I love just literally laying on the ground and just scanning around and seeing how many more stars I can see in the sky with binoculars.
The Pleiades, if you go under a dark enough sky, you can see one or two globular clusters with binoculars. So they're actually really handy to have. But if you're going to look at planets, I would go for something like a telescope.
Right. So now, I love talking about the tools that we can use, but one thing I do want to get back into is observing some planets that we can see without any tools, because I always love recommending some naked eye stuff. So I think we should switch over to Jupiter next? Okay. While we do that, just wanted to say thanks so much for coming. Let us know in the chat if you have any questions for us tonight. We love hearing all of the questions. We love hearing all of the observing tips that you've been looking for. These next ones we're looking at are exciting because they're probably the best ones for observing right now. We saved the best for last tonight. So. Should be good enough for Jupiter. All right, sorry, I was turned around making sure the scope and the roof were lined up. But these last two for the night, Jupiter and Mars, are really the two planets that are best positioned for observing right now. So both of them were recently at opposition, just within the span of the last couple of months. Opposition is when they are opposite the sun in the sky. And so that means that they are up throughout the night and that they are also at their largest apparent size from here on Earth, because we are passing them essentially in our orbit. So it's a great time to observe Jupiter and Mars. These are out even later in the night. You don't have to worry about these setting anytime soon. And they're both really clear and distinct and easy to find with your eyes. So I can definitely tell the atmospheric conditions have for sure been improving throughout this show, because we're getting some good detail on Jupiter. Do you actually want to up the binning a little bit so we can just zoom in a little bit there, Michelle? That would be great. Oh, man.
Dang!
It is.
Wow!
Oh, we hear from Farmer's Almanac joining us in the chat that they're so excited to see Jupiter and Mars. Well, we're so excited to
Farmer's
have
Almanac.
you guys here today. Thanks so much
Gosh, look at
for
that.
coming and supporting us. Wow, Jupiter is great. You know what's funny is
It looks so good.
what we have in our notes for Jupiter is, hey, this is Jupiter. We're not going to stay for long, but this is
Forget that.
looking so beautiful right now. So one thing I want to add is while we've got beautiful detail on Jupiter right now, I also wanted to add that we can't spend a ton of time with it tonight, but that's not because it isn't special, it's because it's so special that we just did a whole show about it. Our very last one was all about observing Jupiter. You want to tell them a little bit about what we had there?
So good.
It looks amazing, man.
Sorry,
I will say, this is a way better
Sorry.
live telescope view than we had at the last show.
I'm geeking.
We have great detail in tertiary bands. You know, we don't just see those two big main bands. You can see some darker portions like down on the polar regions.
Right.
Really clear view of what looks to be the Great Red Spot up there in like the top right corner. Is that right?
I
right
think
here,
so. That's what I'm checking.
it appears to be.
And so actually this
Depends on
gets-
the rotation of the camera, which sort of perspective we see here. It can be flipped from what you might like be expecting to see with the telescope.
So this actually gets into a question that we've got in the chat, which is, hey, I live north of the Adler. Why are the views so good out over Lake Michigan? That's because a lot of times if you're looking out over water, that might help to moderate the view a little bit.
Mm-hmm.
So looking out over water might help. And so that the air currents, it might,
I didn't know that.
there might be
Might be
warmer,
steadier air out
steadier
there.
views, steadier air currents, because over land or over buildings, you're going to have pockets of heat.
Right. It especially helps here where we're so close to downtown Chicago, where
Yeah.
you know the opposite direction is the city. So we definitely like looking over the lake.
Yep.
It gives us a much better view. That is definitely a Great Red Spot.
Definitely the Great Red
That is
Spot.
a lovely view. Somebody asked, is there a coordinate system in the sky similar to latitude/longitude? Yes, there's actually a couple of them. We have altitude and azimuth. We also have right ascension and declination. So those are two different coordinate systems. Their differences are just the lines in the sky that the 0 point is at, essentially. And so yes, we do have coordinate systems that work very similar to that, and that's how we find targets that are not as simple as the planets like this, which are in everyday base.
I'm stunned.
It's a great view. We got a lot of good detail.
And by the way, there are moons, and so the moons, I'll brighten up the image in just a second,
That'd be great, yeah.
They're all on as you see it, the right side, or it'll be the left side.
I'm getting confused by left and right.
Yeah, in the real sky it'll be the right side because our telescope flips images, and so I kind of don't want to overexpose it.
Now, if you want to spot this at home, while you can't see all of these planetary details, Jupiter should be really easy to spot. You can find out, there's a couple of its moons. There's a few more that are present. We'll just need to move the telescope a little bit because they're out of the field of view.
Yeah.
But if you go outside right now, look pretty close to due south and look very high up in the sky, almost straight above you. You can see the angle our telescope's pointed at. Look straight up and you'll see a really bright point of light. You can get your bearings. It'll be near the Taurus constellation. You'll also see Orion right beneath it in the sky. And so this is very bright. Wow, look at all those moons. I love seeing them all lined up on one side there. Which ones are we looking at?
So from left to right, Ganymede, Callisto, Io, and Europa. Or Io, however you want to say it. Io or Io. I'm actually not sure which it is. But so
No.
hang on.
Oh, you're going to get the order back in.
So Ganymede, Callisto, Io, Europa.
Europa being closest to Jupiter, Ganymede being furthest away.
In this perspective,
Yeah,
yes. In reality, Io or Io, it is the closest one, but
geometry gets so confusing.
Yeah.
Geometry gets so confusing.
in terms of how it's Io, Europa, Ganymede, Callisto, in terms of how far they actually are from Jupiter, but because we're seeing
from our
perspective
perspective,
right
yes.
now.
Now, while we're on the subject of the moons, another thing we talked about a lot in the last show was all about the moons and particularly focusing on Europa. We had a guest from the Europa Clipper mission, a planetary geologist that worked on this mission that is currently traveling to Europa right now. So I highly recommend you check that show out. Bella will post the link for it in the chat if you're looking for more lovely Jupiter views and learning more about this really, really complex and interesting planetary system. So honestly, our telescope views were not this good that night, though. We had a much more turbulent atmosphere that night, so it was a lot more shaky than it is right now, much more like the Saturn view we had earlier, but that is just wonderful.
Yeah, I'm taking a little video clip right now while we can, because we can. So give me about another 45 seconds of staring at Jupiter before we move on to Mars.
We'll move on to our last target of the night because it is another really exciting one right now.
Yep.
And well, if I'm gonna be totally honest, in 25 minutes we're gonna have some folks looking right through this telescope.
Exactly.
And so we'll have to. And we've got a pretty hard limit on our show tonight.
I know,
so we're very excited to be able to offer some views of these planets to folks at the Adler tonight. And this is something that we do throughout the year. If you are local or ever visiting Chicago, every clear Wednesday night. We are out here at the observatory. You can keep up to date on that opening time at our group Scopes with the Adler. That is a Facebook group where we update our in-person events and whether or not the weather makes them possible or not. God, that Jupiter looks good. Weather is making this very possible right now. Holy cow, that's the best live view I've seen with the camera.
But if you saw the show at the very beginning when we were showing Saturn and Venus, well, Saturn especially, and it looked very shaky. Because it was only about 25 degrees
low
up
in the sky.
Right now,
it was still windier earlier too.
Yeah.
Winds continued to die down.
Jupiter is currently
75 degrees up, probably.
Something like
really
that.
high up there.
Altitude 64 degrees up.
64, way up there. So it looks beautiful.
Yeah. Oh. I kind of don't want to go on, but we do.
It's always a fun one, yeah. We're gonna have to go on soon. Because Mars, doesn't always get its credit like Jupiter does.
Right.
I gotta say Jupiter and Saturn are the heavy hitters for sure. But now is our one good opportunity to view Mars.
Right. Let's go.
And I'll start talking a little bit about why it is such a good time to view Mars right now. And that's because of that opposition we were talking about earlier. Now, Jupiter was in opposition about a month ago. Mars, or maybe 2 months ago. Mars is in opposition just about 2 weeks ago. And so it's a great time to observe it. And opposition is very, very, I'm gonna hush for the roof moving. Sorry, everyone. A little further. Yeah. Okay. What do you think, Michelle? Close enough? Okay. And so opposition is even more impactful for Mars because of its relative proximity to the Earth and the solar system, right? So that means that the difference in the distance between us and Mars changes drastically, right? So when it's in opposition, when we're on the same side of the sun together, it's pretty close, right? But then when it's all the way on the opposite side of the sun, much bigger difference. So the apparent size of Mars, the size that we see it to be from Earth, ranges from the size of about Uranus and Neptune that we saw earlier, all the way to the size of Saturn that we saw earlier. So a really, really big difference.
Polar cap.
Let's go over to this view of Mars. So it was in opposition just 2 weeks ago. This is about as big and bright as it's gonna get. If you wanna spot this outside, a couple folks are asking which planets are naked eye visible right now. Right now, if you've got a good view to the horizon, you can still see Saturn, Venus, Jupiter, and Mars. After we finish up observing Mars here, we'll pull up that sky map again to show you their updated positions. But all 4 of those are naked eye visible. Mars will be in the eastern sky right now. And so that will be, over into the east. It's just rising up. And you'll find it near the Gemini twins. It has 2 twin stars just above it, and it's right here. So it's pretty easy to spot, and it is very distinctly kind of orangish more than red, but you can definitely see this one with your eye right now. So this looks really great. We're seeing more detail than I expected. I don't know how much you folks can see at home because some of these details are very small right now, but that's kind of just how observing Mars goes. But there are a couple of details we can start to make out. So the things you'll really want to look for are variations in color. Oh, and that extra zoom really helps. So you'll see the sort of base color that you expect, that dusty orange color that's almost like a band across the middle. But you might see along the top some darker regions, maybe even a little dark streak across the middle.
Yep.
And down on the
Polar
bottom
cap.
part, I can see some much lighter part, this wider part.
That is a polar cap.
Yep, and so these polar caps, much like we have, these big frozen caps on Earth, Mars has some similar frozen caps on the North and South Pole. It's actually not necessarily the best time to see the polar caps. They're pretty small right now. But I do think that's probably what we're seeing.
And Geza is asking, is Mars slightly gibbous? It might be. I believe it is. But
Is that what we're getting?
I think so.
What the dark side there you think is phase and not geographic features?
Well, no. The part at the top definitely is a geographic feature.
Okay.
Because I'm bringing up a, I'll show it on my phone. It's a different planetarium, sky program. It's called Sky Safari, and it's got the actual side of Mars that's facing us right now. And as you might be able to see,
It's a little small. You can start to see it up here.
Yep, as you might be able to see.
Well, I also encourage you to check it out on Stellarium or something like that at home too. I will say the phase is currently 99% on Mars. So we should be seeing the entire planetary disk right now. And I especially noticed when it was smaller, the darker geography especially made it look more phase-like.
But that actual dark looking cap is an actual feature of Mars.
Right, geological features, much like you see darker and lighter parts on the moon, right? It can come down to different rocks, different elevations the areas are at. So we are actually able to spot some geographical features on here,
we
which
sure
is
are.
awesome.
The only part that I'm a little hesitant to do is to tweak the focus a little bit, just because it's all the way over here and the computer's over there, and it's a little tough to spot. So it's I don't want to make it markedly worse. I might tweak it just a tiny bit just to see. But you can see that polar cap there.
Absolutely, down on the bottom part of the image, you see where it's almost white like that.
By the way,
I'm really impressed that we can spot it.
If you're wondering if this is live,
yeah, there you
really
go. Tap the scope and it
live.
moves around a lot.
So let me see if I can do it.
Man, really, I think that is a little bit better actually, yeah. I'm really impressed that we can spot the polar cap. I hope that you guys can see that at home. I know that the compression on a live stream can change some of that quality.
That's really good.
That's some really exciting detail to see, and these things show us, how the planets can be similar. I know that they feel like very distant and different worlds. But we see a lot of the same traits on planets like all of these terrestrial planets that we're spotting here tonight. And it's great to see some of those geographical features, because at its smallest, Mars would be, 8 times smaller across than it is right now. I mean, it would be such a small portion of the screen, we're not seeing any of this detail. So it's always good to catch it here at opposition. Ooh, long exposure to see if we can see some Phobos. What do you think? That was a Geza question. Should we try to catch it?
Maybe. What is Phobos's?
Might as well turn up the exposure and see what we can get, right?
Yeah.
I think they
maybe.
probably could be visible.
Let's see. I've never tried. Almost 13th magnitude. We can try.
We'll see. Phobos is pretty close to Mars right now too, as is Deimos. They're both fairly close, so we'll see.
Let's see.
Phobos and Deimos, for viewers at home, those are the 2 moons of Mars. They're very distinctly different moons than Earth's moon is, and leading us to think that they may be captured asteroids. We actually have a image here of an eclipse happening on Mars that really shows the kind of unique shape of it. This is a solar eclipse that was captured by the Curiosity rover in 2013, showing Phobos, one of its moons, passing in front. Were you able to see any of the moons in view with the extra exposure? They're tough to spot. They're very dim. They're really small. As you can see here, they're probably captured asteroids, maybe. Geza's an asteroid expert, literally. That is his specialty, so he might have some opinions on that as well. But they're very different from our moons and much, much smaller. And so we can head back to our Mars view here to finish us off here as we get towards the end of our show. Now, if any folks are, really frequent observers, they might have heard a couple of weeks ago about something called an occultation that was happening with Mars that was visible from here in Chicago. This is a phenomenon where you get to watch something pass in front of something else. So we got to see Mars dip behind the moon one night. This is from one of our telescope volunteers, somebody who helps us with our telescope programming. In the left image, you see it like, maybe 30 minutes, an hour before going behind. And then in the right one, all the way down in the corner, you can see Mars start to disappear there. And in the next one, we have actually a video that you took from your house, right?
I did.
Is this the first documentation you've done of an occultation? I think so, right?
I've never done it before.
We've tried to do shows about it, and it was always cloudy.
Yep.
And so you'll see it march along and eventually disappear behind the moon. Now, you mentioned it being very overexposed here. Why did you have to overexpose the moon here?
I had to overexpose the moon in order to get Mars at the same time. So if I got the moon at its normal look, I wouldn't have been able to see Mars. So I had to sacrifice one to get the other. So that is the moon completely overexposed. But you'll see Mars is kind of that little reddish, orangish dot that's right there. And over the course of about a minute or so.
Mm-hmm. Yeah, we're starting. I mean, you can tell we had some distance between them at the start, and they're definitely right up against each other. It is playing. These things just move slow.
Oh yeah. This is a video that I took using my DSLR camera. So
we had somebody in the chat asking if we would share the photos of the planets after the stream. Well, one thing I can offer is we will have the live stream up afterwards that you can go back and check on, but we have been taking some pictures throughout the night, and I can't guarantee those will be up super soon, but we can work on getting some of those uploaded. We can put those in. Bella in the chat might have a better idea of where those will end up, but maybe in our Scopes with the Adler Facebook group or somewhere. But I imagine Bella can give you a heads up of where that's possible.
Let's go back to Mars.
Let's go back to our live view to finish the show off. I mean, oh my goodness. Way better than I was expecting it to. We've got so much good detail in there.
Guys, this literally is the best view of Mars we have ever gotten. Great. This is amazing.
I'm glad that our seeing conditions were so good.
Yeah.
One last question. Somebody asked, why is Venus so green? It's somewhere between green and yellow, I would argue, when you see it. I would say through the telescope, it's very bright white.
Yes.
The clouds are very white and reflective. They might be referring to the images we saw from the surface, which look much more green and yellow hued. That is because of that sulfuric atmosphere that you have on the planet.
That and probably someone just applied a filter or something or it's how the image was processed. But Venus definitely is not green. It also depends on what you're looking at it through. If you're looking at it through a lens of some sort, you might be getting differential refraction of color.
Yeah, I think we had some of that when we had our telescope view up near the phase, like the shadow. You could definitely see like some more coloration there that I don't know if it is really real that we're seeing from here.
It might also have been our camera setting.
Right.
So yeah, this is definitely more.
This is a much more accurate color.
This is much more accurate color for Mars. Venus, I'm still thinking, also because it was relatively, we're looking through a little bit more air when we're looking at Venus, and so don't take that as what Venus really looks like. Just the color. Anyway.
Right.
So.
I was wondering if they were maybe referring to. We looked at a picture of this Venus from the surface of Venus.
Yes.
And that it does have that strange colored hue to it, which comes from its atmosphere. So I don't know which one they were referring to there.
Probably the Venera. Image,
yeah. And so that one is kind of an off-putting image, and it's all the sulfur in the atmosphere. It's just a crazy place, very different from Earth. Well, what a lovely view of Mars tonight and of Jupiter, of so many things. Venus looked great. I hope that you guys at home have enjoyed getting to look at all of these with us. Before we end our show, I do want to give you one last little update on how you can go out and see these planets. So we showed you last where their positions at 5:30. These are their positions here in 15 minutes at 7 o'clock. So you can see Saturn and Venus getting lower in the sky.
Central time.
But yes, sorry, this is Central. This is all Chicago time. So you may want to check this just to see exactly where they are relative to your location. But you can see Mars much higher now. Jupiter basically due south. Those two will be your easiest to spot. You can see them near the Orion constellation. Lots to look at in the sky right now. So I encourage you to go out, get some of your views of your own. Download Stellarium if you need some extra help to determine which ones are those planets tonight. But man, This has been a great show. Do you have
Yes.
any final words for the folks at home? I mean, I think we should end it off on our lovely Mars view that we have
I
through the
agree.
telescope, because that's what we're about to do for the next 3 hours is Mars view through
Yep.
this telescope. It's
Yeah.
not moving off of that for a long time.
Yep.
So.
And so, yeah, the last thing that I'll say is if you happen to be in Chicago, you're visiting, you're local, come on down to the Adler on a Wednesday evening. And if it is clear out, I mean, we're open every Wednesday evening, and it is Illinois Resident Discount Day, or Discount Evening. So for Illinois residents, every single Wednesday, free general admission to the Adler Planetarium. Get your tickets online. And if it happens to be clear out, as it is tonight, the observatory is open. And
Yep.
so we're going to be open from approximately, it might be a few minutes after 7, but 7 p.m. Central till 10, or a little bit before 10. Sometimes we have to close a little bit early because we want to get through the entire line of people by 10. So if basically the rule is if the doors open, come in.
Come on in.
Come
Yep.
on into the observatory.
We love having you come and look with us. If you go outside and snap some pics of these planets following the show, tag the Adler Planetarium, use the hashtag lookup. We love seeing all of the observing that you guys do when right alongside us. That's what the show's all about, is getting you outside to appreciate the night sky. If you've enjoyed the show tonight, subscribe down below. You'll get notified when future episodes of Sky Observers Hangout are happening. Meet us here on the Adler's channel at midnight on the evening of March 13th. It's technically March 14th by then. So midnight March 14th, we'll be live for a total lunar eclipse, another
Yep.
really exciting one from down in Carbondale, Illinois.
Exactly.
So other than that, thanks so much for coming out, and we will see you next time.
Bye, everybody.